Hello students, today we are going to see some more interesting and important questions from M.S Chouhan's Organic Chemistry, Aldehydes and Ketones, Level 1, and the question from 101 to 110. Come on, let us discuss these questions. The first question, an optically active compound C6H12O gives positive test with 2,4-DNP, dinitrophenylhydrazine, 2,4-dinitrophenylhydrazine. It will be answerable. That means the compound C6H12O. This compound will be answerable for 2,4-DNP. 2,4-DNP, dinitrophenylhydrazine, it will be answerable. And negative with tolerance reagent. So here only they have given the key. So what is the compound? So this is answerable. Answerable. Right. So answerable means this is 2,4-DNP will be answerable for both aldehydes and ketones. Both aldehydes and ketones. Right. Okay, so 2,4-DNP will be answerable for both aldehydes and ketones. So that means this is positive. And negative is what it is? Tolerance reagent. This will not be answerable for tolerance reagent. Okay, so tolerance reagent. There they kept the key. Okay, so tolerance reagent reacts only with aldehyde. So tolerance reagent reacts only with aldehyde. So it does not react with ketone. Does not react with ketone. So that means the compound might be keto group only. Ketone. So negative for what it is? Tolerance. Negative for what it is? Tolerance reagent. So that means the compound might be what it is? Keto group. Okay. In that keto group also, here actually methyl keto group, they mentioned very clearly optically active. Optically active. So optically active means what it is? It is a chiral compound. What is a chiral compound? Chiral compound. Right, chiral compound very clearly I just mentioned in that isomerism videos. I have solved all the isomerism questions, only 1 to 200 questions, just to check it with that. Okay, now chiral means nothing. All the different groups are atoms attached to that carbon, that is called chiral carbon, and that compound, it is chiral compound. Right now this is for A, B and E, F. All different groups are atoms attached to that. So that is optically active also. So that means in that compound which is chiral compound, so that compound might be chiral, then only it will be answerable. So that means a chiral means 4 different groups or atoms attached to that. Okay, now everywhere methyl keto group it is available. So here also methyl group it is available. Here aldehyde, so it will not be possible because tolerance reagent will be answerable for only aldehyde, but here negative for aldehyde. Tolerance reagent do not react with keto group, so this will not be possible. And here also methyl keto group it is there, and here also keto group is there, but methyl keto group, that is the main thing. And the second point what it is here, one more point they mentioned very keenly. They mentioned optically active compound. Optically active compound means that should be what it is. 4 different groups or atoms, it has to be attached. So methyl group it is there, but 4 different groups. Here there is no 4 different groups are there. Okay, so this will not be possible. Of course, B, it is not possible. And D, you just check it here. Here it does not have 4 different groups because both are same group, CH3. This also CH3, this also CH3. So it is not possible. So option C, let us check here. Carbon and hydrogen one side, methyl group is another side, CH2, CH3, that means ethyl another side, and methyl keto group is another side. So 4 different groups. I just mentioned here carbon, which is hydrogen one side, and this side what it is? CH2, CH3, ethyl is another side, and this side methyl group is another side, and the fourth one C double bond O, CH3. That means 4 different groups are available. Now this is one group, and this is another group, and this is another group, and this is, so 4 different groups. So this is actually optically active group. Yes, optically active compound. So this compound C6H12O 100% option C only. So even you just check it, carbon 6H12, 1 2 3 4 5 6. Yes, carbon 6 12. How many hydrogens are there? Here 3 plus 2 5 plus 3 8 9, 9 plus 3 12, and oxygen only 1. I hope you got that idea. Now which is the exact answer? I think now you know the answer. Option C is the correct option, right? Got it? I hope you got the clarity about this question. Now in this question, which is the correct option? Option C. Come on, let's go to the next question. Even you will come to know the trick also. The 2,4-DNP it will be answerable for both aldehydes and ketones, and the same way tolerance reagent will be answerable only for what it is, aldehyde only. It does not react with the ketone. So these are all the main points to note down. So at once you will get that idea when you know the short tricks, right? The next question, compound A, C6H12O3, when treated with iodine in aqueous sodium hydroxide gives yellow PPT. See, the compound, it is actually what it is, C6H12O3. Right now, when it is treated with iodine along with NaOH, this is completely iodoform test. Sodium hydroxide with iodine, it is iodoform test, and it gives yellow PPT. So that means iodoform test is only answerable for methyl keto group. That is very important. Okay, as I mentioned, as I'm reading this question, I'm giving that idea. So iodoform test will be answerable will be answerable only for methyl keto group. Only for methyl keto group. Methyl keto group. Okay, so these are all the trick. So you please remember. Okay, so what is that question completely? So this is only for iodoform test, only for what it is, methyl keto group. It will be answerable. So that means that compound might be keto group only. So when A is treated with the tolerance reagent, no reaction occurs. So 100% this is not an what it is, aldehyde. Why? Tolerance reagent only will be answerable for what it is, aldehyde only, and it tolerance reagent will react with aldehyde and forms what it is, silver mirror test it forms, right? So it does not react with the keto group. So 100% aldehyde. Here there is no aldehyde, keto group only 100%. That is also what it is, methyl keto group only 100%. When A is hydrolyzed and treated with the tolerance reagent. Now you see, when A compound is hydrolyzed and treated with the tolerance reagent, that means it will be answerable. That means here what it is, silver mirror is formed in the test tube. So this compound also, this keto group also, when it is hydrolyzed and then it is treated with the tolerance reagent, it will be answerable that you are getting that silver mirror test. Now in that compound, which is the correct option. So here tolerance reagent first, it does not react. So that means here option A, B, C, D, which is the correct option. So here in that option D, aldehyde group, it is there. So aldehyde will not be answerable. So this will not be the correct option. Okay. Now because as they mention in the trick, as they mention in the question only, we just cancel some of the important points. Right now here option D, it is not possible. Option A, actually this is what it is, CH3 C double bond methyl keto group, it is possible. Here also methyl keto group, it is possible. Here also it is available for methyl keto group. Why I am mentioning methyl keto group will be answerable for what it is, iodoform test. Second key what they mentioned, when it is it will not react with the tolerance reagent, but not the point, but when it is hydrolyzed and treated with the tolerance reagent, it will be answerable. So that means hemiacetal, that point only we have to note down, because here I just wanted to mention the main important point. Compound, this compound A, that is C6H12O3. So this compound hydrolyzed with water, it will be answerable for hydrolyzed and react with tolerance reagent. Okay, so react, I just mentioned that idea, react with tolerance reagent, then it will be answerable. So that means acetal group converted to aldehyde. Hemiacetal do not convert to aldehyde. So this is, I wanted to mention, these are all the trick. So acetal, so I just mentioned here acetal. You know acetal group, you know, no, right? So acetal group can be converted to aldehyde. But which is cannot possible, hemiacetal. You know what is it, acetal and hemiacetal, you know very well, right? So hemiacetal cannot be, these are all the trick, please note down, cannot be converted to aldehyde. These both I just wanted to mention here what it is, during hydrolysis, that is the main point. So this is happening, conversion is happening, no, this is happening what it is, during hydrolysis. Right now let us check each and everything. Now in that first one, what it is here, the first last option, it has gone. Now let us check the first one. So this is actually here OH it is there, this point it is OH it is there, here OH is there, and here OCH3 it is there. So OH one side, OCH3 is another side. So this is completely hemiacetal only you will be getting. Why? Because when it is hydrolyzed with water and reacts with silver mirror test, just now I just mentioned, no, the trick. So hemiacetal do not convert aldehyde, right? So that means this cannot be possible. Option A, it is not possible. Why? Because it is forms hemiacetal only when it is hydrolyzed with water. Then when if you are getting that hemiacetal, so it is not possible to convert aldehyde, right? Now the second one, that means option B. Option B, it forms a diketo group. Here also keto group it is there. And this, if you hydrolyzed with water, here also keto group only it will be forming. So that means two keto group. Here also methyl keto group. Here also you will get what it is, C double bond O. Here also another C double bond O you'll be getting. So that means this also will not be possible. I hope you got the clarity. So diketo group, during hydrolysis you will be getting this compound, especially this compound you will get a diketo group only. I hope you got the clarity why this option is wrong. See, when you go for hydrolysis with water, so this also it will be going away and you will get what it is, keto group. That keto group, both this side also keto group, it is like this side also keto group. Diketo group, how it will be answerable for tolerance reagent? That means here what it is, it will not give aldehyde, right? Aldehyde only will be answerable for silver mirror test. So this will not be possible. I hope you got an idea. Yes. Now option A, option B also correct. Option D also correct. Option C only it is pending. Okay, the same idea. I just bring that here. So option here this is CH3, C double bond O here. C here what it is OCH3 and here also OCH3 and here CH3. So that means here yeah this point here CH no sorry CH. So CH means when you hydrolyzed with water H3O plus. So hydrolyzed with water. Okay, so you will get what it is CH3, CH3, C double bond O. It is there as it is. Now here what it is CH2. Here what it is C double bond O H. Now this point CH3, CH2, C double bond. So that means what it is aldehyde group it is available. So aldehyde group will be answerable for what it is Tollens test. So this will be answerable for Tollens test. Tollens test. So Tollens test will be answerable for aldehyde and forms what it is silver mirror PPT. Silver mirror. The formation of silver mirror you will be getting in that what it is side of the test tube. Okay, I hope you got the clarity. Now which is the correct option? So you will get the option here that option C is the correct option. I hope you got the clarity why C is correct, why A, B, D it is not correct. See, very nicely they have given the question and analyzing. Seriously, very easy to understand. The concepts are really great. You please note down the trick so that it will be easily you can adapt to that question and very fast you will answer. Question CH2 CH2 COOH CH single bond CH2 CH2 COOH when it is reacting with barium carbonate, the calcium carbonate like barium carbonate, when you are heating up you are getting a compound A, right? Now that is compound A reacts with NH2 and KOH. This is Wolff-Kishner reduction, right? I hope you remember Wolff-Kishner reduction. You are getting compound C. Now Wolff-Kishner reduction it will be answerable for what purpose? Conversion of carbonyl compound into hydrocarbon. So that is the main keyword. So this one adipic acid, this is called what it is adipic acid. So CH2 CH2 COH single bond CH2 CH2 COH, it is basically known as adipic acid. Adipic acid combined with the barium carbonate like calcium carbonate. So you are losing what it is formic acid. So when you are losing formic acid you are getting what it is keto group. Keto group combined with the Wolff-Kishner reduction you are getting the product hydrocarbon. Come on, let us check how that reaction carry over. Right now here CH2 COOH single bond CH2 COOH combined with BA what it is BaCO3, right? BaCO3 barium carbonate. When you are heating up you will get what it is formic acid relieving HCOOH, right? HCOOH. So you will be getting what it is keto group. No, so keto group how it is possible CH2 C double bond O, that means 2O it is there. No, it's the same CH2 here also C double bond O. Okay, this is pentanone, right? 5 carbon it is available, 5 carbon that is connected with the keto group. So this is what it is pentanone. So this is what it is pentanone, that is what. So like this I just put it. So this is pentanone. Okay, double bond O. So when this one which is reacting with what it is NH2 hydrazine, right? NH2 along with the KOH. I just mentioned this one. So this is Wolff-Kishner reduction. What do we call Wolff-Kishner reduction. Wolff-Kishner reduction. So you are getting what it is keto group which is converted to hydrocarbon. You know very well. So I think this aldehyde and ketone all these videos you observe number of times I just mentioned. So this is completely H2. So that is what C double bond O which is converted to CH2 reduction. No, so that means cyclopentane you will get it. So cyclopentanone which is converted to cyclopentane. Cyclopentanone which is converted to due to that Wolff-Kishner reduction cyclopentane. See, even Wolff-Kishner reduction and Clemenson's reduction both are doing the same process. One it is in acidic medium, one it is in basic medium. Now I think you got an idea which is basic medium, which is acidic medium. Wolff-Kishner reduction we are using what it is KOH, it is a basic medium, and Clemenson's reduction it is an acidic medium. I hope you got an idea. Now in this question which is the correct option? Here in this question cyclopentane is the correct option. See, very nicely the questions they have given. Really it is very interesting and easy to adopt the concept and bring out that important points to be noted down. So please note down this trick and see like carbonyl compound converted to hydrocarbon. That is because of what it is, Wolff-Kishner reduction. At once you just think, because here NH hydrazine they have given hydrazine with KOH 100%, it might be Wolff-Kishner reduction. That much confident you should have, so that you will get the exact fast. Because here there is no calculation. Here completely based on memory based questions as well as understanding, logical way thinking, everything you have to bring it out, right? Come on, let's go to the next question. So which is the correct option? Option C is the correct option. The next question, which of the following does not react with sodium bisulfite? See, actually, what is the character of sodium bisulfite? No, sodium bisulfite convert carbonyl compound into crystalline. That is a matter, but it does not react. That means sodium bisulfite do not react with steric hindrance. That means crowding compound. Okay, crowding compound. Say especially what it is, steric hindrance. Right. Okay, now come to that point. So that means it will, where it does not react, only that they are mentioning, right? So that means here aldehyde group it is available, so that means it will react. Okay, so here methyl keto group it is available, here also it will react, right? Methyl keto group it is there, here what it is, ethyl group it is there, so that means methyl keto group it will be answerable. Sodium bisulfite it will be answerable for methyl keto group, right? And the same way here also methyl keto group it is available. You see here methyl keto group it is available, so here it will be answerable, here it will be answerable, here it will be answerable. The question does not react, so that means that everywhere we put it symbol, no, so you will get doubt. So where it will not react, so does not react means here ethyl group it is there, so ethyl group, methyl group only, methyl keto group only it will be answerable. So that means CH3 C double bond O CH3 or CH3 C double bond O CH2 CH3. This also will be answerable. Why? Because here methyl keto group it is there, here methyl keto group it is there, but it does not answerable for diethyl ketone. So that means what it is, CH3 CH2 C double bond O, here CH2 CH3. So that means this is a steric hindrance, crowding group, wherever crowding it is there. So sodium bisulfite will not go and visit, right? Because too much of soldiers are available, so it will get affected by the soldiers. That means steric hindrance. So it will not go. Whom will not go? Whom it does not go and react? Sodium bisulfite. So this will be the correct option, which is the correct option, which does not react with the sodium bisulfite. The diethyl keto group will not react with the sodium bisulfite group. I hope you got the clarity. So which is the correct option? Option C is the correct option. Come on, let us go to the next question. I hope you got the clarity about all these points. Sodium bisulfite means what purpose we are using and where it will react, where it will not go and visit only. Right? Come on, let's go to the next question. Here the compound A, actually this compound, when it is reacting with Raney's nickel reduction point. Okay, so you are getting what it is, compound A. That means the product A. What is the product A? Right. Now this is actually very interesting question only. I just mentioned the question for you to understand. Here actually what it is, this compound which is connected with C double bond O, and then here CH2. How many CH2? 1, 2, 3. Right. CH2, CH2, NH2, right? When you are heating, after heating only it goes for Raney's nickel reduction point. Okay, this is also very powerful reducing reagent. Okay, it's actually a powerful catalyst, Raney's nickel. Okay, now come on, when you are going for that, now what happened here? 1, 2, 3. Right now here when you are going like this, here double bond it is there. No, here 1, 2, 3. Right, so here only nitrogen it is there along with H2 here, right? So what happened? These both will release water when you are heating. See, generally when you are heating, no, you are losing the water. Water will go for evaporation. So what happened? You will get the double bond, right? So you will get the double bond. So how you will find the double bond? Now you see here like this compound, right? Now double bond N and the same like this, right? You got it now? See, double bond O as it is. So this point, when it is reacting while heating, what happened? This hydrogen H2, when it is combined, you will get, it releases water molecule and you are getting like this. So here Raney's nickel it is appearing. What it is, Raney's nickel? Raney's nickel actually a powerful catalyst reducing reagent for the hydrogenation. So usually what happens when you are going for the catalyst Raney's nickel? C double bond N reduces to C single bond N. This is what conversion takes place when you are going for the Raney's nickel hydrogenation. I hope you got the clarity. This is a trick. Raney's nickel, for what purpose we are using? C double bond N. Here C double bond N it is there, no? So C double bond N, which is converted to C single bond N right now here. So you are getting the compound what it is. The compound will be like this, it shows right now. So here like this and here. N, and here this hydrogen, one hydrogen will be there for CH2, it is there, no, so generally CH2, one hydrogen which is replacing N, the other hydrogen it is handled. So this is cyclohexane attached with piperidine. This is a piperidine, right? 6 4. 1, 2, 3, 4, 5. So that means this is piperidine right now. So this is that compound. It will appear as that compound A. Right now, I hope you got the clarity. How do we identify? The same, very simple, but it is very important and interesting. Also, this hydrogen which is combined with oxygen releases water. So you will get C double bond N. So C double bond N when you are adding with rannies, nickel. So that is actually a very good, powerful catalyst. And what is that speciality? It releases, that means it reduces that C double bond N to C single bond N. So you are getting like this compound attached with, so cyclohexane attached with the piperidine. This is piperidine. So which is the correct option? Option C is the correct option. How come option C? Now here oxygen it is available, this is not possible. And here benzene, here actually hexagon, no, how come it is benzene is possible? No, this will not be possible. And a single bond, that means double bond it is there. How come here double bond will be coming here? Nothing, there is no double bond, right? So this will not be possible. See how many confusion they are giving now. Really, if you are confident with your answer, you are able to solve all the sums right now, all these problems, right? So option C is the correct option. That's what I just mentioned. Cyclohexane with piperidine. So usually this part it is called piperidine, right? Option C is the correct option. I hope you got the clarity. Come on, let's go to the next question. Next question, dicyclohexanone react with this bromopropene, right? KOH. So this is really interesting question. Why? Because this is bromine, this is a leaving group. So naturally this will be attracted towards where there is a active methylene group. So this is an active methyl group, right? So active methylene group, it will go and attach, right? Okay, now I just draw the structural formula here, KOH. So you're getting product A. So what is that product A? Let us check here. Now here this compound here, what it is? Dicyclohexanone 2 keto group it is available. So here double bond O, here double bond O. This is actually what it is, active methylene group, right? Active methylene group. So this is, very well, it is more acidic because only one hydrogen it is there only, it is acidic, but it is more acidic. Why it is more acidic? Because 2 keto group in that middle, this is also functional group, this is also functional group, in that middle 2 H plus ion is available, so it will be ready to donate that acidic proton, right? Okay, when it is reacting with the CH2 double bond CH CH2Br, right? So this is, as I mentioned, this is a leaving group. So this which is attracted towards that active methylene group, right? So what you will be getting? You will be getting what it is, the same thing which is going to attach over here. So it does not affect the C double bond O, right? So it will be attacked with what it is, active methylene group only. So what you will get it, that is CH2. So this part which is going to attach CH single bond CH double bond CH2. I hope you got the clarity. CH2 CH double bond CH2. Right now here, next to one, what it is, you'll be getting here KOH is there, no, here KOH, due to that KOH only it is affecting, right? So basic medium, right? So you will be getting the product, what it is, this product only. Here I just draw again the structural formula for you to understand. Here keto group do not affect with KOH, right? Here CH2 CH single double bond CH2. So this is the product you will be receiving. I hope you got the clarity. So which is the correct option? This will not be the correct option because this is alive. So it will, alive means what it is? It is there, but here there is, it is not going and attaching, right? This is the wrong option. Here it is active methylene group. Here it is, no, this also will not be the correct option. How come this methyl group? Here also methyl group. Why this partiality? Right now this is also not correct. And exactly active methylene group, it is going to attach. So which is the correct option? Option B is the correct option. I hope you got the clarity. See, actually if you've known all these ideas like trick or tips when you are learning the concept ideas, so then time only you are able to solve such kind of problems. Okay, come on, let's go to the next question. The next question here, the compound, this one C double bond, here C double bond C COOH. So this is acid group combined with methyl lithium excess. So you will get compound A, and then this compound reacts with I2NaOH. This is iodoform test. So you are getting compound B and iodoform. That is okay. Now a simple trick I would like to tell you. Here COOH is there, no, C double bond OOH. So this OH will be replaced by methyl group, right? So methyl group, methyl lithium, no, methyl group. So when methyl lithium, methyl group, when it is attached with the C double bond O, so that is methyl keto group. Methyl keto group will be answerable for iodoform test. Iodoform test only, methyl keto group will be answerable for iodoform test, right? Wherever methyl group it is there, methyl keto group it is there iodoform test will be answerable. Then you will get related salt, that is COONA you will be getting. Okay, I just draw, write that equation so that you will be easily understand. Okay, now here, this, I just draw here, this is the way it is now. Hexagon, here double bond. So here double bond also, here C and here COOH, right? I think you got an idea. I just draw the structural formula. Here O, here OH. See, that is what here they mention, no? See, double bond. Here C, in this corner C, and then COOH. Right. Here, excess of methyl lithium. And along with what it is, HCl, H2O. So, you will be getting what it is? You will be getting C double bond. Here, it is same as it is, nothing to worry. C, it is there. And then C double bond O. Here OH releases in that Me, which will go and attach. So Me is also, we can write it here CH3. Why? Because here methyl keto group will be affected by I2NaOH. What it is? I2NaOH, NaOH, or iodoform test. So iodoform test will be answerable for what it is, methyl keto group. So you will be getting related salt, right? So what you already they mentioned CHI3. Right, so in that CHI3 you will be getting, right, another one here you will be getting what it is, same hexagon, it will be there, double bond C will not change, C will be there, and then here what it is, C, and here double bond O, here ONA. Right, now here this point which is released and this ONA which is going to attach. So I hope you got the clarity how to solve this. So that means this this is the compound. What compound they are asking? The compound B. This is the compound B. I hope you got that's what related sort of COONA. Yeah, now in that which is the correct option. So iodoform test here COONA. Option B, how come it is possible? This will not be possible. See how nicely they are giving confusion. COONA, because 2 carbon it is available. See, here one carbon, here one carbon. Directly double bond which is not going to attach with COO2, right? So this will not be the correct option. Right. And the same way, how come it is possible double bond comes over here? Right, there is no double bond. No, here there is anything double bond. No, this also will not be that correct option. I hope you got that. That is what purposely I just mentioned here. Double bond C, COOH. That is what purposely here. One corner is there. No, corner shows carbon. Right, got it now. Which is the correct option? Option A is the correct option. So this is what I just wanted to explain. C double bond. I mean this carbon C double bond C, and here in that point only COO. That means CO2 Na. I just draw the structural formula. This is the compound B. Right, got it. This is nothing. Right, so option A is the correct option. The next question here, cyclopentanone conversion with that this transformation. Arrange the following reagent in the correct order and which above transformation is carried. See, really it is very impressive question and tricky question also. Like we have to identify that rearrangement one reagent with which is correct order. Okay, now first and foremost cyclopentanone, here D it is there. So here they mentioned KOD. It is nothing here. I just mentioned here KOD. It is deuterium, KOH only. We just mentioned here KOD. So this is actually very strong base. Okay, so first and foremost KOH when it is reacting, so naturally it will go and affect the alpha hydrogen. This part it will go and affect, right? So that means it will not affect that what it is keto group. It will affect what it is alpha hydrogen point. Right now here alpha hydrogen can be replaced with the deuterium. Right now here this point I just draw the structural formula for you to understand. So this is a double bond O, and this point it is called what it is, alpha hydrogen part. So this, because this is a functional group, so this is the alpha hydrogen part, right? So alpha hydrogen can be replaced. Okay, can be replaced with what it is, D. So how many D's can be possible here? CH2 only, no. So that means 4 D's possible. 4 D's possible, right? Alpha hydrogen can be replaced. So cyclopentanone, so that means here I just KOD. So you will be getting that compound here. Here what it is, same as it is C double bond O, and here what it is D, and here also D, and here also D. What it is, deuterium. That is what purposely I just mentioned here, D, and here also D. Right now here what it is, so this 4D that is occupied, right? Now the carbonyl carbon can be reduced with an alcohol. So C double bond O. See here in this point it is C double bond O is there, no? This point here C double bond O is there, no? So C double bond O can be converted to what it is, COH. That means which one can be used here in this point? Lithium aluminum hydride. So lithium aluminum hydride, it is a very strong reducing reagent. Carbonyl carbon can be converted to alcohol. So this point, I just to bring this point. So lithium aluminum hydride we have taken. So in this point here, what is it? Here you will be getting alcohol with 4 D's, right? So you'll be getting alcohol with 4 D's. D, and here also D, and here also D, and here also D with OH. Why OH? Because lithium aluminum hydride we are using a strong reducing agent which is convert carbonyl compound. That means carbonyl group into alcohol group, right? It has converted. Next to one, what it is? Here you will get H plus ion to change, convert this transformation. What transformation? Here the transformation is here, no? So here it is actually to release a water molecule. So here actually D is there, no? HOD. right? So that means here what you will get it, so you will releases the water molecule HOD, right? Means H2O, that is what I just mentioned, HOD. Who's HOD? Chemistry HOD. Right now here, so you will be getting, it releases water. No, it releases water means that bond comes over here. Here it is anywhere, this side or that side, this side or this side. D, and here also D, and here one D only it is available, because another D which is joined with OH, you are releasing H2O, no, HOD. H2, no, HOD, right? I hope you got the clarity. Yes. Now which is the correct option? First one KOD, second one D2O, we are not using D2O, we are not using that, right? So this will not be the correct option. Yes, this will not be the correct option. And H plus, first starting only, we are not using H plus ion. This also it's not correct. Lithium aluminum hydride, second step only we are using. So this will not be correct option. KOD, first we are using after KOD bar D2O, and lithium aluminum hydride. Here also KOD bar H2O, and we are heating last finally lithium aluminum. So this will not be the correct option. I did not see this. Okay, now lithium aluminum hydride, it is, we are using second step, third step, we are heating, right? Of course, we are heating. Here we are heated up. When you are heated up, you are losing that water molecules KOD, HOD, right? DOH also you can mention. Okay, now which is the correct option? Option C is the correct option for bringing this transformation. See, double bond is there. Yes, here also double bond it is available. See how nicely they are bringing the questions now. Seriously, very interesting, and this is the way they are asking in the JEE mains also. Come on, let us go to the next question. The next question, CH3, C double bond OH, that is aldehyde, combined with the HCN. You are getting compound A, that is hydrolyzed with water, that is acid hydrolysis. You are getting compound B. Again, you are heating compound C, lithium aluminum hydride, that is compound D. This is actually a strong reducing agent, and HIO for hydriodic acid. So this is, you are getting formaldehyde, and E. Compound E we have to find out. The compound C can show geometrical isomerism. Product E of the reaction will be. Now compound C, if we know means compound E we will come to know. So here what it is, aldehyde, that to acetaldehyde. Acetaldehyde, when it is reacting with HCN, really it is very interesting, like puzzle making it, is that? Okay, CH3, C double bond O, H, combined with HCN, okay, HCN, right? You are getting what it is, CH3. This is very easy. Okay, so addition of this OH, and here CN, this is nucleophilic addition reaction, right? Okay, again you are going for hydrolysis, H3O plus acid hydrolysis. You will be getting acid CN, which is converted to acid, that you know very well, right? So you will be getting what it is, CH3, C, here what it is, CH, the CH, here OH, and here COOH, right? COOH. Why? You know, this carbon which is converted to acid. Right now, this is the compound B. This is a compound A, and this is a compound B. Right now, the next point, what it is? Dehydrating. Now, you are heating this compound. When you are heating that compound, actually, it releases the water, right? Now, that means here, you will be getting what it is. When you are heating this, no? So, two molecules be required for this. For that, I just draw the structural formula, CH3, CH, here O, and here C double bond O. And the same way here, CH3, here CH, and here C double bond. That means two molecules. Now I just mentioned two molecules, C double bond O, and here O, because they mentioned compound C will be what it is, like geometrical isomerism. No, that is the purpose I just draw. I hope you got that idea. Now these both, it is accompanying. Okay, compound C shows geometrical isomerism. Okay, so here is that point above, and here is the compound below, right? Right now, yes. Now that means geometrical isomerism, right? Now the next point, what it is here, this which is going to react with lithium aluminum hydride. So lithium aluminum hydride, it is a strong reducing agent. Lithium aluminum hydride, in that last question also I just mentioned lithium aluminum hydride. What happened? It's C double bond O, which is converted to OH. So two molecules, right? Two molecules, these both combine. I'm just bringing, right? Okay, now here in this point, so here you will get what it is, CH3, CH, double bond CH2. Here OH you will be getting, and here what it is, here also you will be getting OH. Why? You know, actually here alpha beta unsaturated system can exhibit cis and trans isomerism. Right now here, actually what is that exact product here, what it is, I just mentioned here, CH3, CH double bond CH, COOH. So this is crotenoic acid. Crotenoic acid is actually what it is, alpha beta unsaturated system. So alpha beta unsaturated system, alpha beta unsaturated, alpha beta unsaturated, this can be exhibit what it is, cis and trans isomerism, right? Cis and trans isomerism, right? So that means here CH2OH, right? So that means here you, when you are going for further hydriodic acid, HiO4 hydrochloric acid. So again it releases what it is. Already they mentioned here HCHO aldehyde, and here you will be getting again the compound, original compound you will be getting. What is the original compound? Original compound, what it is? Acetaldehyde. Right, acetaldehyde you will be getting. That is what I just mentioned, original compound. So here actually when we go for this one, this is actually very easy. We will follow this HCN hydrolysis again. Cyanide can be converted to acid group. This also again this compound only we will get confusion. That is what purposely they mention geometrical isomerism. Geometrical isomerism means what it is? Cis and trans isomerism. Cis and trans isomerism you know very well, right? Cis trans, that you know very well, right? Okay, now in that lithium aluminum hydride, if you are going reducing that lithium aluminum hydride, what it is? Acid CO group can be converted to what it is? Alcoholic group. Then you will be getting, suppose if there is alcoholic group here, you are mismatching this point. Here OH has to be, here also OH. Otherwise, no, the compound you will not get that. Actually, from acetaldehyde only you are getting this crotanoic acid. Okay, so that is what purposely this will be answerable. I hope you got the clarity. So this is the cis and trans isomerism. Right, come on, let's go to the next question. So which is the correct option? Option C is the correct option, because CHO, that means CH3, CHO, same thing, it is available, right? Formaldehyde already it is there. Now again formaldehyde it is not possible. And here actually how many carbons are there according to that? Here where is the double bond? It is available. So in that way 4 carbons are there. No, so here 3 carbons and here 1 carbon. Formaldehyde already there is a product they mentioned, you know. So here 3 carbons and here 1 carbon. So 4 carbons is available, right? I hope you got the clarity. Now what is the correct option? Actually option, it has to be the answer. Acetaldehyde only is that original starting product and starting reagent only, reactant only, right? See now which is the correct option? Option C is the correct option. Yes, it is standing there right now. Which is the here option C. Right now here keto group will not be possible. Here of course this is aldehyde, but acetaldehyde 4 carbons. 1, 2, 3. Here 2, and of course here in this point it is changing, right? So this is the way, right? CHO this point and then HCHO. That is what when you are going for hydrochloric acid, the bond breaks. CH3 C double bond OH, and here HCHO. So CH2O, right? I hope you got the clarity about this question. Now, which is the correct option? Yes, you are agreeing with that. HCHO answer is available here. Option E. I mean, E product E, it is acetaldehyde. That is what same reactant I just mentioned. Right? Come on, let's go to the next question. The next question, arrange in the increasing order of equilibrium constant of hydration. Hydration, it is nothing like HOH, no? So this is nucleophilic addition reaction, right? So nucleophilic, when we are comparing these compounds, like what it is, keto group, aldehyde group, this is chloro keto group and HC double bond OH, and again this is aldehyde with the chloro group. Right now, I would like to say the main important points to be noted down here. The first point here, what to say here, aldehyde and ketone, when we compare aldehyde, it's more reactive. Aldehyde, it's more reactive than ketone, than keto group, right? Now the second point here, chloro group also it is available, no? So chlorine, here also chloro group is the component, here also chloro, right? Now for this minus I effect, we can bring it minus I effect. So minus I effect, what it is, increase the reactivity toward nucleophile, increase the reactivity, towards what it is, nucleophile, towards, these are all the important hints. Please remember, for that is the reason I'm bringing these points. Nucleophile. So these are all, you please note down in one what it is, cheat notebook, right? Okay, so so these are the points to be noted down when we are arranging these things. Right now in that option A, keto group, which is more active, more reactive. So aldehyde group, it's more reactive. That means this is least bother. Only here it is here, yeah. So that means least reactive. They are asking increasing order, right? So that means A is the least one. A is the least one. Then second one, what it is, AB, it is aldehyde, it is very fast reactive, and here chloro group it is there, here also chloro group, and here also chloro group. Of course here keto group also it is available. So C is another point of a little bit higher level comparatively A. And then next one, what it is, next one B, of course what it is, here also aldehyde group it is there, no? So aldehyde group or aldehyde group it is there, D it is there, C it is, E is there. So that means aldehyde group it is more reactive. Then comparatively E and D, which is more reactive, here formaldehyde, and here chloro group it is there. So actually E, because here also what it is, aldehyde it is there, and minus I effect, so E it is there. And formaldehyde it is more reactive than acetaldehyde, because here there is no methyl group, right? What it is, like soldiers, There is no methyl group, it is their steric hindrance in that way. So there is no crowding group right now. So that means here D. So this is increasing, which is more reactive, means aldehyde, aldehyde only. In that more reactive, formaldehyde, it is more reactive, and then acetaldehyde, then chlorogroup, in that is generally aldehyde. So I think you got an idea. ACBED, where it is ACBED. ACBED. Yeah, option C is available. So option B is the option B. ACBED. ACBED. Yeah, option B is the correct option. I hope you got the clarity. Yes, come on. Let us go to the next question in our next video. I hope you understand all these questions. And thank you for watching.